As a space scientist, a lot of people ask me, why are we investing so much time, money, effort in space when there are these huge challenges here on Earth? And that's a really valid question. It's also one that I'm not going to answer now in this 15 minutes. What I can do is try and assess half of that equation, right? I can try and tell you a little bit about the space sector and what it's doing for our everyday quality of life, but also for the world as a whole. So, essentially, there are four main themes for what we do in space. The first one is space science. This is things like the James Webb Space Telescope, right? That's trying to find the nature of the universe, trying to find what is dark matter, dark energy. Is there life outside the Earth, somewhere else in the universe? These big questions. The next set would be communication satellites, right? When I phone you, that doesn't go through space, right? When we use the internet, that doesn't go through space. Most of the communications that we rely on for every day doesn't go through space. But there are places in the world that don't have access to high-speed, high-capacity fiber optic internet, right? There are places in County Durham, up in Weardale, that don't have access to high-speed, high-capacity internet, right? As a solution to this, a lot of people are turning to satellite communications. And that's an enabler of key facilities like global education, healthcare, finance, entertainment. That's all enabled by satellite communications. The next set is Earth observation, right? This is things like telescopes that are looking downwards rather than upwards, okay? So we're looking at trying to measure our weather systems that fill into weather forecast models. We're looking at climate modeling, okay, which can help us potentially mitigate the effects of climate change. Then we have navigation and timing. We're all aware of what satellite navigation is. We all use it daily, even when we don't need to, right? And the way that satellite navigation works, essentially, is things like GPS, which we're all aware of. And we get timing signals from 4 different satellites where we can trilaterate our location on the Earth. But the way that works is through these timing signals, and those timing signals are more important than just for GPS, for example. They're also used as time synchronization points. So whenever we send financial transactions, that's time-stamped, and it has to be time-stamped very precisely, because if those synchronizations start to come out of time, then those transactions will be rejected, because we can't tell what order different transactions have happened in. Okay? I can tell you about the size of the space sector in terms of numbers. Right? We've already had some big numbers here today. The global space economy is worth about $500 billion. Right? It's projected to grow to $2 trillion by 2035. These are big numbers. In the UK alone, the space sector is worth £20 billion and supports over 50,000 jobs. It's a huge sector that not many of us are aware of so much. If we include all the other companies that rely on space in order to do their daily business, then the value of the space sector to the UK economy is apparently worth about $370 billion. That's about $1 billion a day, right? This is huge. But really, big numbers, but anyone like me, it doesn't really mean anything. It has no context. It is big, but how big? What does that mean? So instead, let's do a thought experiment, right? Let's assume that one day we wake up and we've got no connection to the satellites, right? It's just gone for some reason. Don't worry about why for now. We'll come across that later. So what's the first thing we notice? We notice that we lose all those satellite communications, okay? Which, for the early adopters up in Weardale, that's going to be a bit of an issue. The planes are grounded, the ships return to port because they don't have GPS. There's chaos on the roads because everyone's trying to find those paper maps that we used to use. Right? The emergency services are disrupted because they don't know where the incidents are. They don't know where they're going. There's no fleet management from the dispatchers in the office. So everything is becoming quite hard. Our weather forecast gets even worse, right? That's an issue for other sectors like fishing or agriculture. We lose signal to our telephones and our internet. This is an interesting one, because I've already told you that data doesn't go through space, right? But actually, to have a high-capacity network, something that's really operating on the edge, to get that really high bandwidth, the amount of data that goes through our devices every day, that requires a really optimized network, and that requires time synchronization. We start to lose synchronization, then all of our sophisticated networks grind to a halt. Those financial networks, the telecommunications network, it all slowly grinds to a halt and becomes unusable. Industry is going to struggle, right? The price of oil and gas goes through the roof because we've got no shipping, right? All the ships are in port. The financial sector crashes because our financial payments aren't going through. They're all getting rejected. The stock market crashes because we're trying to sell things before we bought it because we can't agree on a global time. All of our power distribution networks, they all fail because there's no synchronization between supply and demand, which leads to power surges and damage and delicate infrastructure. There's no food on the shelves when we go to our shops. That's not necessarily a problem because you've got no money to pay for it anyway, right? But this whole thing, it builds and it builds, and before you know it, you've got no power, no food, no money, okay? This AI web generation for images wouldn't let me develop a visualization for that, so instead we've got chaos in purple. But I think it shows the scale of it, of what's going to happen. We could try and fall back to terrestrial technology, but that doesn't exist anymore. It doesn't have the capacity that we rely on. How realistic this image is probably up for debate, right? This is a worst case that we're going for. But I think it's clear that without the satellites, that would have a significant effect on our daily lives, more than most people realize. But is it possible? Well, there's 3 key causes of such an event. The first one could be coronal mass ejection. So this is charged particles that come in a big wave from the sun. Those charged particles can corrupt the memory in the satellites. And are often accompanied by large magnetic fields that can induce current and therefore damage our delicate electronic equipment. So your satellites become inactive and uncontrollable. The other option could be cyber or conventional warfare. We already have examples where certain states have destroyed their own satellites as a demonstration of capability. And the third option is space debris, right? There's a lot of satellites up there now. When they crash into each other, they're traveling at 8 kilometers a second in low Earth orbit. So it's faster than a bullet, right? And something the size of a van is going to hit, huge energies involved. That creates a lot of debris. That debris then goes around in orbit and hits another satellite, which creates more debris and so on and so forth. And you can imagine those first 2 on there could easily lead to the third one. But space is big, right? So is that likely? Is that actually something we really need to worry about? So here's a visualization of space. Each of these little green dots is a satellite, which is in the database of satellites. There's about 10,000 up there in the middle, 10,000 satellites up there at the moment. You can see that it's sort of clustered in the middle. That's where the Earth is. You can't see the Earth because of the visualization here. There's a few dotted around in the middle and this ring around the outside. There's 10,000 of them. But in order to launch satellites, we also have to use rockets, right? So it turns out that there's actually lots of rocket bodies up there still in orbit. There's about 2,000 of them. They're particularly bad because they're enormous and full of rocket fuel. So if there's any sort of accidents, then that creates a lot of debris. We have inactive satellites, things that have come to the end of their life. Another 3,000 inactive satellites. Uncategorized, okay, so there's a lot of things that we can see up there. We can track it using radar, LiDAR, whatever we want, but we don't actually know what it is. That's most of it turns out. And then track debris. So this is debris that's already up there from previous anti-satellite demonstrations, for example. Another 10,000. So in total, we've got nearly 40,000 tracked objects. Now, we know from our work in Durham that that is incomplete, right? We see things all the time that are not in this database. But even just including this subset, we've got 3,000 collision warnings at any one moment. All of these are essentially ignored because we don't know which ones. We can't possibly do everything. How do you tell someone that they need to move their satellite over there? Nobody knows. We don't have that system in place. Okay? Here's another demonstration, right? This is an animation of Durham City tonight. These are all of the satellites that are going to go over the city. Okay? There are loads of them. You can't see them all by eye, right? But they're there. You can see them by telescope, and this is a big problem for astronomical observers as well. So this is a really active and dynamic environment, and nobody really knows where everything is or where it's going. What we need is some method of space traffic coordination, right? We need to be able to understand where all those things are, where they're going. We need the technology in order to understand the environment. We also need the governance. We need the rules of the road. We need some way of understanding, okay, if there's a projected collision between these two objects, who should move? Who has right of way, right? What's the highway code for space? And we need some coordination. Okay, you've got someone, an operator in America, an operator in the UK, and there's a projected collision. What do we do about it, right? How do we communicate? How do we make these decisions about operational procedure of companies and states? Okay, this is all big questions that we don't currently have the answer for. The space sector is rapidly evolving, right? This is required now. Now is the time to start thinking about this. Here is a plot of all of the objects launched into space from the very beginning, in the 1960s, beginning of the space race, right through to now. And you see that most of the time, okay, we're launching tens of satellites a year, right? And these tend to be big, defense-funded communication satellites, generally the size of a van. And then around about 2015, something happens, something changes. And what that was reusable rockets. Reusable rockets brings down that cost of launch, which means that companies are able to launch new satellites and smaller satellites, which enable new applications and new activities. And satellites are now the size of a shoebox rather than the size of the van, okay? And this is set to increase. So whereas in the early 2000s, it was $55,000 to launch a kilogram into space, now we're looking at $1,000 to launch a kilogram into space. That's the change in scale. For the cost of the admissions that all you paid to be here today, we could have launched a fairly sizable satellite into orbit. But the point is that there are a lot of what I've spoken today has been quite a call to action, right? Quite negative. But the reason that that is happening is because of the opportunity from using the space as an application, right? We can do things like mitigating climate change. We can bring communications to the whole world. And that's only possible by solving some really quite technical, but also communication or governance-related challenges. We need people who are creative in their problem solving, right? This isn't just about rocket scientists. So the final message for the people in the audience that are looking at careers, okay? The space sector isn't just for rocket scientists. It's for anyone who wants to solve interesting problems that can really tangibly change the world, okay? Space is for everyone. Thank you.
Thank you. It's fascinating. I saw your presentation already, and I still learned a lot hearing it today. So, one of the questions is why are there so many more? The graph towards the end with the explosion of commercial launches. What's driving that? What are these companies doing?
It's cost, right? So now it's cheap enough to try something, whereas before, when we wanted to launch a satellite, it would cost you hundreds of millions of dollars of development and launch. Now you can do it for a few $1,000s. So you can try something. There are companies out there who want to use infrared telescopes to look down and see where heat is leaking from buildings.
Right.
You couldn't have done that, right,
Okay.
10 years ago because the cost would have been inhibitive.
Huh. Okay. So it's I guess that magic of the private sector where people can pursue these various different missions that centrally located NASA never would have thought about.
Exactly.
Look down telescopes from the sky to see building heat leakage and things like that. Okay.
And this is all driven by SpaceX initially. Elon Musk, whether you love him or hate him, has changed the world.
Yeah. Interesting. Okay.
Yeah.
And so here in the Northeast, is there growing activity in this sector as well? Then?
There really are, yeah. So there's a Space Northeast England is a cluster that we have up here, and it's growing very, very quickly. We've got lots of industry and academic involvement, with a real focus on communications and space sustainability, actually. Okay. And there's a strategy, and the strategy for the Northeast of England is to get 10,000 highly qualified space jobs in the Northeast by the end of the decade.
Cool. Okay.
Which is huge. Yeah.
There we
And
go.
it's amazing to write that on paper, right? To actually write down a number in a strategy is very impressive.
And the work that you and your group are doing, where are you hoping to, in 10 years' time, what might be different coming out of there?
That's a good question. So in Durham University, we've just started a new space research center, Spark, as we call it.
Was there a rumored £5 million involved in this or something?
Yeah, so the university have invested to start this, right?
Okay.
And all of that investment was to go into people. So we're trying to build that hub of expertise, but it's very interdisciplinary. We don't just want the technology experts. We need the people who are thinking about the space law to understand the technology and the environment. So you need that link between the technology and the lawyers and the international relations to understand how we can get that message out. So it's really complicated and complex environment that we're trying to work in.
Fascinating. Because they're notoriously tight fits, I understand. I don't have any direct experience dealing with the university. And so why are they laying down such a large bet on your stuff? Or do they just really like nerding out on space stuff, which is popular?
It's an opportunity, right?
Okay.
It's an opportunity to do things that universities are good at. What we really need are new ideas. Okay, we're at the stage in the space sector where an idea can make a difference, as I said. And that's exactly what the university is set up to do. Okay. So by joining these different people who generally perhaps are quite siloed, by bringing them together, we have an opportunity to do something even bigger.
Okay, well, so literally watch this space.
I reckon.
Fabulous. Sorry. Thank you.
Thank you.
Cheers.